will be by itself. All right. So the graph is translated dash dash. Can you describe that, sir? The graph is translated dash dash.
3 units up.
You got it. Can you fill out the other one? You can graph it to get the picture. And so what do you got for the description? Move up or down? Down. Cool. Your mind. So we read it, X belong to real. Okay. What do you think the restriction going to be? Y belong to real, where Y is? No, it's not going to be greater because it's -5. It's -5 and about. Oh, you just say greater than or equal to -5?
Yeah.
Okay, yes, you're right. And then what's the transformation?
The graph is translated 5%.
Correct. So now we're going to conclude some of them. The graph of Y is equal to fx plus c and then minus cr, vertical translation. All right. When c is greater than 0, the graph is translated. When c is greater than 0, the graph is translated as right c units, isn't it? I mean up, not right, up c unit. C is less than 0, down. The point x comma y on the graph is transformed into x plus y plus c. So you can see an original point from the graph will move it to x coordinate doesn't change. The y coordinate will change by y plus c, isn't it? Are you following this logic, sir? So y is equal to fx. If I take a point, let's think about y is equal to x squared. A point in x squared. So when x is 2, y is 4, isn't it? And then on the other hand, y is equal to x squared plus 5. So how do I get the same point here? The x doesn't change, but the y will be going up by 5 units. You see that? The original graph, if I have a point 2, 4, on the transform graph, because of the 5, you only chipped in the y value, not the x value.
Yeah.
Right? By how much is 5? So it's going to become 2, 9. But remind the x value reminder, same. Did you get the picture?
Yeah.
Okay. So now, for your practice, you're going to be doing investigation 2. So I want you to calculate those values and try to graph. So can you plot those? If you have a calculator, you can plot it. Keep the answer in fraction or decimal. There are times you're going to get a decimal number. But can you plot those values for x and see if you can draw them? So we're going to see the next observation. Plug in the original function, right? For example, first is x plus 2. So 1 over -4 plus 2, isn't it? So this is negative 1/2. Are you following that? How do I plug it?
Yeah.
Okay. Can you plug both graphs and try to plot those points and see what's happened in the graph? How's it going? Did you get the points? Okay. Did you sketch the graph? So the original graph is given to you. So what did you notice when you scratch the graph 1 over x plus 2? Did you try to plot the points on the curve? Plot those points, you got it, right? For example, you got -4, -1/2, isn't it? So -4, -1/2 is a point that's going to be someone here, isn't it?
Yeah.
Okay, can you plot all the points and then try to connect those points like a curve and then see what did you notice?
For -2, when I put in my calculator, I thought not there.
Sorry, which one? When you put 0?
When I put -2,
-2 for which one?
the first.
Yes, so that is undefined. You can do 1 divided by 0, isn't it?
Yeah.
So that's undefined. So that's basically even the same thing, right? So what do you get? -3? It's a -1, isn't it?
Yeah.
Okay, and then this is -1 is going to be -1 plus 2 is going to be 1, isn't it?
Yeah.
0 is going to be 1/2, right?
Yeah.
So let's plot those points to see. Let's show you how the graph will look like. So -4, -1/2, -3, -1. So that's going to come over here. And then -2 is infinity. So I'm not just going to do that. What does that mean? I'm going to put a little line here because my graph cannot cross the line -2. Make sense? I see that. My graph cannot cross the -2 line because any value -2 for that graph is going to be undefined, isn't it? All right. Keep going. -1, -1. So -1, is come here. And then 0, 1/2. So 0, 1/2 here, isn't it?
Yeah.
Okay. So technically, it's not quite easy to graph it. I'm going to show you what's going to happen. The graph is going to be go something like this. So this is going to be simply bent toward this line. And then similarly, the graph is going to be simply goes like this, right? So go through those points and goes like this. Now let's see. You see the line, a vertical line. Do you see the vertical line -2? We call that asymptote because your graph is not crossing the line. And when a graph is not crossing a vertical line or horizontal line, we call asymptote. But because it's vertical, we call vertical asymptote. So this line is a vertical asymptote. Vertical asymptote. And we know the vertical asymptote is going through the x value, x is equal to -2. So the vertical asymptote here, I'm going to say x equal to -2. You see that? With that line. Now, what do you think has happened to the blue curve and the green curve? What did you notice? What exactly probably happened to get the green curve from the blue curve? What exactly happened to get the blue curve to green curve? Something we talked about yesterday. You see this move this way, isn't it? You see that it's moved this way?
Yeah.
So it's moving horizontally to the left, 2 unit. Do you see that? So if it is plus in the middle, it's horizontally moved to the left, minus is moved to the right. So how are we going to say state the domain? Well, the domain in this case, x belong to real. And then we see x cannot be 2, isn't it? X cannot be -2, isn't it? Right?
Yeah.
The range in this case, y belong to real. But if you can see, the y is not equal to 0. It's not crossing the y-axis. Did you see that, sir? The green curve is not touching the y-axis. So it can take the value 0, isn't it? So can you just do the next one, second one? Let's see if you can graph the second one and then tell me what's going to happen. Y is equal to 1 over x minus 3. Yep. So what do you get the domain? Using the same idea, what do you think the domain? So when you substitute 3, what do you get? Matter also is undefined, right? So because at 3 we got undefined, so what do we say is it's x belong to real, but x cannot be 3, isn't it? You see that? Right? So x belongs to real, but x cannot be 3. So what about the range? Y belongs to real, but y in this case not equal to 0 because it's not going to cross the x-axis. If you draw that, you can see it. So in the other way, what does translation do? It's going to move my blue curve right to that 3 unit. So if I really want to draw it, all I need to do is 1, 2, 3 points, right? And then I'm just going to take 3 points here. So I'm just going to simply move that 3 points. So this is 1, 2, 3 points. So it's going to be go 2 unit to the right like this. Like, see that? Right? And the blue curve is also going to come. So it's going to be through, it is not going to cross this line. So we can put this 3, it's going to be my asymptote. So it's going to something like that. And this guy's going to be go something like this, right? Because it's going to move 2 unit to the right, right? Are you following the picture? All right. So the graph of y is equal to fx minus d is a horizontal translation, isn't it? So where d is positive, the graph is translated right. When d is negative, the graph is translated to the left. The point x comma y on the graph is translated by the following. So if you have a point x comma y, you can see this time it's only affecting the x value, not the y value. Can you see that? Previous one, we changed the y value. So if you can recall, previous one, the y value has been updated, right? X plus y plus c. Did you see that? Right? All right. But now you can see it's x plus d plus y. So that means the x value changes, y value remains the same, isn't it? Oh, sorry? Yes. So let's going back to my original curve. So if I have y is equal to, let's going back to y is equal to 1 over x. So let's choose a point. If I have a x value 1, y value is going to 1, isn't it? 1 comma 1, right? Yeah. On the other hand, if I'm going to have my curve y is equal to 1 over x minus 2, so what is going to happen? Y value doesn't change. So y value still remain a 1, but the x value is going to be go to the right by unit. So it's x plus d 1 plus 2. So the new coordinate is going to be 3 comma 1. Make sense? Are you seeing that? Right? Yeah, write it down, yeah. So that's simply affecting the yx value, that transformation. Similarly, if 1 comma 1, if I have y is equal to 1 over x plus 3, so this is going to be, when it's plus 3, then we're going to subtract. So what transformation is going to be? 1 minus 3. So that is going to be negative 2 comma 1, right? Are you following that, sir? If it is minus, we simply add. If it is plus, we subtract. Are you following that horizontal transformation? How does this being affected? The original curve has 1 comma 1, right? So we try to see if I horizontally transform, you don't really move the graph up and down. You simply move the graph as it is. So it doesn't change the y value. So only you're moving in this way. It's in the same height, right? So the only thing is happening is the y coordinate remain the same in a different x value. So how to find x value? We simply add the value of t, right? You got the picture? Okay. So now going back to a few things here, describe the, starting with the parent function, describe the following transformation. So we're going to describe it. So I'm going to do some examples, you get a sense of it. So if you see this g of x, the parent function is y is equal to x squared. This is my parent function because you see that something squared plus 3. The original function is y is equal to x squared. So what we're going to do, we're going to describe the transformation. So when we describe the transformation, we will tell everything happening from left to right. So left to right. So we talk about this is the vertical guy, isn't it? Outside is vertical. Inside is horizontal. And you got a plus 5. That means it's going to move to the left. So we're going to say horizontally translate. Horizontally translate to the left. by 5 units, isn't it? And then vertically translate down, up by 3 units. Make sense? Did you get the picture, sir?
Yeah.
Okay, can you complete B and C? Because same functions, different keywords. Okay, so how do you describe B?
Horizontally translate to right 5 units.
Yeah.
And vertically translate down 3.
Okay, so horizontally translate to the right by 5 units, and then you say vertically translate down, isn't it?
Yeah.
By 3. How about this verbally? You can tell me.
Horizontally translate left by 1.
Yeah.
And vertically down by 4.
Vertically translate down. You can't miss those words. Okay. So now, why say that? It's the same idea here. We're gonna go from left to right. Pretty straightforward. So can you think about the next one, sir? Verbally. Same idea. The outside is vertical, the inside is horizontal, isn't it? So how would you tell the first one? Yeah, horizontally.
Translate.
Yep.
To the right.
Yep.
By 2 units.
Yes, and then?
And vertically translate up 8 units.
You got it. That's it. So you know how to do D, E, and F. Okay. So now they're simply giving you, rather than giving you actual function, they want you to think about what this transformation you need to apply for f of x, right? So inside is horizontal, outside is vertical. So for example, if you look at the first one, I can obviously say horizontal translate to the right by 3 unit, vertically translate up by 4 unit, isn't it?
Yeah.
So inside is going to be horizontal, outside is going to be vertical. So all right. So now that's pretty straightforward. B, C, and D. It's pretty straightforward. So let's see if you can verbally tell B. They switch around the numbers, but you should be able to tell. They switch the 5 and function out. Yes, what's happening?
Horizontally translate to the left 1 unit. And then
Yep.
Vertically translate.
You got that right. So yes, C. Okay, C. There's nothing outside, right? So only inside. So what do you think is gonna happen?
So horizontally translate
Yes. If it is a minus, is right, and positive left, right?
Yeah.
So horizontal translate to right, 7/4 unit. Okay, D.
So if it's left.
Left is positive, and then minus is minus is positive, and then positive is to the left. So if you have a minus, you're going to move to the right. Just opposite of the sign. You can see always positive mean go to the right. Here, positive mean go to the left. Okay, last one.
Horizontally translate left by 2 units.
Yep.
And vertically translate up 2 units.
You got it. So now the next part of this is a little tricky. So what next part is a little tricky? There are several curves given to you. So I'm going to talking about the curve that you can easily remember. So parabola, we talk about what the shape is, isn't it? An absolute value function will take a V shape. It's always straight line and with a V shape. So anything with a V shape is connected to a function defined inside these two parallel lines, right? If a V-shaped function, if you have a V-shaped function, it's something defined inside the absolute value sign. So the absolute value is basically saying, forget the sign, get the value. Forget the sign, get the value, right? Now, if a function goes like this shape, this is something in the form of 1 over, right? Reciprocal function. Did you see that, sir? If a function is going to be giving you a shape very similar to resemble something like that, if a function resembles shape like this, or if a function resembles shape like this is something 1 over something, right? Function. You get the picture? You see how to like look at for the shapes?
Yeah.
The last not least, the square root function will only go on one side. It can go this way, it can go this way. Anything that curve like that is a square root function, right? So what we want to see is, this is a thinking question. So in this case, the question is asked to match the curve. So to match the curve, you need to ask yourself, by looking at the function, you just get to looking at the function first. By looking at the function, you can ask yourself, what kind of shape the function should resemble? So you can see this is whole thing squared plus 3 quadratic function, isn't it? Yeah. Now you're going to be asked yourself, okay, what's happening to the quadratic function? It's look like, you can see, move to the right 2 unit, and move up 3 unit. So all you need to look at for the graph, that probably from the origin, move to the right, and then went up, right? So can you be able to tell me in A, B, and C, and D, which graph resemble like that? Something that moved to the right from the origin, and then move up. Which one of that shape, the parabolic shape, resembled that? Moved to the right and went up. You got it, sir. That's it. Right? Now let's go back to the B. If you look at the B, this is something, the 1 over x curve, right? Now let's look at the 1 over x curve. That's moved to the left by 2 and went up. The 1 over x curve, right? The curve that's C shape in both sides, it's moved to the right, left by 2, and then went up. So which curve do you think moved to the right by 2 unit and then went up by 1 unit? So from the original position, it's moved to the left. Moved to the left. It should be moved to the left, right? In another way, you can think about a curve, because x is not defined in -2, right? Which curve is not touching x equal to -2? Which curve is not really touching x equal to -2 axis? Because of x plus 2 is not defined in -2, right? Which one of the curve is not really touching in -2? That's how to think. You got it, sir. That's it. So now I will do a square root one. So let's look at the square root function. So let's look at that D. So if you look at this D, A, B, C, D, right? So we want a square root function, because inside you got -3. That means it's moved to the right by 3. It's a move to the right side from the origin, and then went up. So which graph do you think shifted to the right side from the origin and then shift up, but have a shape something similar to like this? It should be resemble a shape like this, right? This is the curve. This is the shape, right?
Yeah.
A shape like that. It's actually move away from the origin to the right because of the -3, and then went up.
Oh, B.
So yeah, that's it. All right. So I'm not doing the other ones. That's for you to practice. All right. That's for you to practice. There's a lot of talk about here. I didn't see. If I want to come back those questions, I'm going to come back that question later because I want to go back to the next transformation. Okay. So let me fill out this table. Absolute value. How does it work? So absolute value of negative x. So when you have it, so we're going to talk about horizontal vertical translation. So absolute value of -3 is +3, isn't it? So absolute value of -3 is +3. So it's -3 because the minus outside. You see that? Right?
Yeah.
And then absolute value of -2. So this is going to be -2. Absolute value of -1 is going to be, so this is going to be simply 1. So -1, it's going to be 1, -1, 0, we don't care, 1, -1, 2, -2, 3, -3. So we got the negative numbers because of the negative sign outside, isn't it? The third one, 3 times absolute value of -3, which is 3. 3 times 3 is 9, isn't it? Are you following how I calculate that? Now 2 times absolute value of -2, 2 times 2, 4. And then we got, I mean, I'm not doing that correct. I got 3 in the front. So what I'm doing is 3 in the front, absolute value of -2, 3 times 2 is 6, and 3 absolute value of -1, that's going to be 3. And then you got 3 times absolute value of 0, which is going to be 0. And 3 times absolute value of 1, it's going to be 3. 3 times absolute value of 2, it's going to be 6. 3 times absolute value of 3, which is going to be 9, isn't it? You got that? Okay, can you write a plot those points on a graph and observe what's happened? I want you to plot those points so we can talk about the observation.
I plotted.
Hmm?
I plotted.
You plotted. So what's happening to the first one? What do you think happened in the first graph? The first one. What the first one is doing?
It's reflected.
in the x-axis, isn't it? So that minus will reflect on the x-axis. What do you think the second one is doing? It's a graph is narrower. It's come inside the blue curve.
Second one's
Narrower, right? So we talk about this. The number outside, if it is a -1, is going to be reflect on the x-axis. And then this number, if it is greater than 1, is going to be stretched by a factor of 3, right? Now, this one, it's going to be wider. If you do the math, you can see the graph is going to widen. So wider because it's less than 1. The number in front of is less than 1, right? Wider is called compress, right? And then sometimes you also see both negative and the number. So the last one is going to do two things. You know what the last one will do? It's going to be reflected and also make it a curve narrow. Make sense?
So if the number is smaller than 1,
It's compressed, wider and compressed. And we're going to write that on the bottom, sir. Don't worry. So when A is less than 0, the graph is reflected in the x-axis, isn't it? Open down. Look at that summary. When A is greater than 1, so the number in front of it, the graph is vertically stretched, isn't it? When A is less than 1, the graph is vertically compressed. Are you following that? Keywords? It's going to be expanded. So stretch is going to be making narrower, right? Narrower than original, right? Now you have to be careful. These are done vertically. So what you're thinking, so when you say compress, you're thinking this way. We're not compressing this way. We're compressing this way. Vertical compression. That's why it's going to become wider. When you have a graph, when you stretch it this way, when you stretch your graph vertically, the graph became narrower because you're holding here and then push it this way, stretch it vertical, right? When we compress it, we vertically compress it, so it's going to become wider. You push this down. You see that? Oh. So you're thinking compressing this way. We're not compressing this way. We're compressing vertically. That's why the graph is going to become wider. Think about it, pushing it something this way, and this is fixed. It's going to be malleable, isn't it?
Yeah, yeah.
Right. Yeah. We're gonna come back to the next one that you're talking about. It's horizontal. We can also do horizontal. We can do the same thing horizontally. So horizontal is going to be opposite. If you're going to horizontally, you're going to stretch it. It's going to be wider, and if you're going to horizontally compress, it's going to get narrower. Make sense?
Yeah.
Okay. That's the next investigation we're going to see it. All right. So why don't you give a shot in graphing this? You might need calculator for some of them. Can you graph the first one? Plot the points for the first one on the original graph. You'll see what's going to happen. Y is equal to square root of 2x. So you might need a calculator to get some of those values. Actually, no, you don't really need a calculator. It will work out nicely.
I did the first two.
You get it first two. Okay. What observation you see the first one, sir? Oh, so just higher than it's going up. Okay, so we're gonna say if you do the 0, 0 is gonna be 0, it's gonna be 1, 2 is gonna be 2, there's gonna be 3, isn't it? So 0, 0 that point, and then 1.5, 0.1, 0.5. Okay, I just said 0.5 is gonna be 1. So it's gonna go here, and then 2 is gonna be 2, and then 4.5 is going to be, so 4.5 is going to be 3. So that goes like this, isn't it?
Yeah.
Okay. Now, the question for us is, so we see the graph, right? And then we want to see how that possible to get the curve. So this is something that you need to visualize it. So my question here is, when do you think if I do what to my graph, you think it comes like that. I'm thinking about a blue curve. So if this is a fixed point, what should I do to my blue curve to get the red curve? This is fixed, this point is fixed.
Gotta stretch it out.
Oh, well, let's stretch it out, it's gonna go like that, it's gonna still slant. So think about it, I'm compressing horizontally, sir. If I compress horizontally, it's gonna go out. You see that? Make sense?
Yeah.
So that's our visualization. And keep it, if I push it this way, this is go up, isn't it?
Yeah.
So now we're gonna see how does that work? Like what kind of things has been done? We say, you see, this time the number 2 is in front of x, isn't it? The number is in front of x. So it's not outside of x, but inside the x, but in front of x. So what we call this, that 2, take the 2, we say horizontally, we see its compression, isn't it? Compressed by a factor of, this time, you see the factor, we're going to be the factor for this curve. I'm writing for this guy, okay? We say factor of 1/2. We say horizontally compressed by a factor of 1/2. So all we're doing is, the number 2 is inside, we are changing it the reciprocal. You see that? So the reason why is why that happened. Why did I say horizontally compressed by a factor of 1/2? That's a big question. Like, what should I do that? So we need to observe that. So why did they say horizontally compressed by a factor of 1/2, right? So let's going back to my original curve. So I want you to observe the original curve. So let me think about some point, x, y. This is for y is equal to square root of x, okay? So let's think about some point. So when x is 0, y is 0. When x is 1, 1. When x is 4, it's going to be 2. 9 is going to 3, isn't it? You see that? Those are the points, right? Square root of x. Are you following that? Are you following that?
Yeah.
Okay, now going back to y is equal to square root of 2x curve. So we're going to copy down the corresponding, watch it. When x is 0, this is x and y. Look at this value. When x is 0, y is 0, x is 0. When y is 1, x is 0.5. When y is 2, x is, when 1.5. 2 is 2, right? 2 is 2. And then when y is 3, this is 4.5, isn't it? Are you seeing that, sir? You see that I copy the other ones, right? So I copy the points from this curve. That's here. Are you seeing that? This is the points from this curve. Here. Those are the points from that curve.
Yeah.
Now I want you to observe. Let's look at the y value. Do we have the same y value both places?
Yeah.
Okay. But now let's look at the relationship of the x value. 0 divided by 2 is 0. 1 divided by 2 is 4 divided by 2 is 9 divided by 2 is. So what's happening here is our y value doesn't change. The x value is being halved. You see that? The previous one, vertical, when we do vertically this way. So when we did vertically this way, the y value changed. But when we do horizontally this way, y value remains the same, only x value changes, isn't it? So here, we do your horizontal, you see horizontal change in x value, y value remains the same. So there are 2 places y value remain the same. You move horizontally, left or right, y value remains the same. X changes. Here, y value remains the same, but the x coordinate being halved. Because of being halved, we say it's compressed. And when that happens, if the value inside is greater than 1, isn't it? And then what did you observe of the next one? Did you draw the next one? Well, y is equal to 1 square root of. Did you graph it?
Yeah.
What's happened? Underneath. So now think about it. How that possible to get underneath? If I pull this curve this way, instead of compression, it's going to come underneath, isn't it? Smaller. Imagine somebody's pulling this way, right? So if I'm stretching this way horizontally, it's going to come down. If it compresses, goes up.
Yeah.
So You see the observation, right? Okay, so now the only difference is, so that's we're gonna call, for this one, we're gonna call horizontally. So I'm gonna write that, horizontally compressed. Actually, horizontal stretch, and only you can see that. By a factor of, we flip it. So that is 2. Make sense? Are you seeing that? And the last one, this is the same as this. Can you try to roll this one and tell me what's happened, sir? Bicycle square. The last one, D, fourth one. Try to graph it. What do you think?
He reflected
Reflected on the
y-axis.
y-axis. You got it. So when the minus come inside, reflected on the y-axis. Come outside, reflect on the x-axis. That's it. That's what advanced functions learning is about. This is why people fail to visualize it. So when you visualize it, you see exactly what happens. Moving this way. Yes, moving narrower this way, wider this way, and narrower this way, wider this way. That's it. That changes different things. Anything we do vertically affect the y, anything we do horizontally affect the x. So let's summarize this. So when k is less than 0, we reflected on the y-axis, isn't it? Make sense? When k is 1, the graph is horizontally. So k is greater than 1, compressed. So we flip it here, right? And then it's stretched. So you see that? Are you summarizing that?
Yeah.
So all we're doing, sir, when we have the horizontal value, so we're gonna call if graph f of x became k time x. So the k time x do the horizontal step. So k time x. Then if you have a point x comma y, that changes into x over k comma y. Do you see that how that changes? We talk about it. We have to divide the x coordinate by the k value, right?
Yeah.
Okay. Now we summarize what we learned. So here's the possible things can happen. You ready? We talk about the D and C in the grade 10 class. D is going to move horizontal, left or right. C is outside, going to move up and down, isn't it?
Yeah.
A is going to be stretching on vertical direction. K is going to do stretching on horizontal direction. Make sense? Are you seeing that? Okay, so let's see if we can fill that out. So let's point back how we identify this value. So first example done for you. So you can see that. Let's go back here, sir. The A value is 1 because there's nothing in front of F, isn't it? A value is 1. Inside, K value. Outside, the D, C value, isn't it? And then D is 0 here. Are you seeing that how I identify those values? A is 1, K is 2, D is 0, C is 3.
Yeah.
So we see first, we're going to go back to left to right horizontally. So we're going to going back to the horizontal translation first. Horizontally compressed by a factor of 2. So why do we do that? Horizontally compressed by a factor of 2 or horizontal stretch by a factor of 1/2. So this is basically the 2. You see that 2? So 2 is horizontal. Don't use that. Just can say horizontally compressed by a factor of. I will take the first line out. Don't confuse it. So when this 2, this is incorrect. Horizontally compressed by a factor of 1/2. There was a mistake because we just talked about that. We need to flip it, isn't it?
Yeah.
Okay. And then the other thing is vertically translate 3 unit up, isn't it? Vertically translation because of the 3, isn't it? Are you following that?
Yeah.
So I'm going to let you to complete the table. Fill out A, K, T, and C, and let's see if you can get that right. Back. And then try to write the description of the transformation from left to right. Okay, then turn on the lights. Let me see. What did you do the first one? Just hit the first one. So you got a is minus 1. We're thinking about k. D is not right, sir. Then this is plus. The D is going to be k is opposite. So plus means minus 1 minus 3 constant. C is minus 4. That's right. A is you got it right. You're still thinking about k. So there's no k because k is something in front of x plus 1, right? So in front of x plus 1, there's nothing in front of the x. So k is 1. Right? Are you following that?
Yeah.
K is 1, we don't compress or stretch horizontal. Right? So k need to be greater than 1 or less than 1 to be horizontal stretch or vertical stretch. But if A is 1, we don't do anything vertical. Right? Okay. That's yeah.
So horizontal separation by 1 unit to the left.
Yep.
And vertically translated down 3 units.
How come 3 units? Where you got 3 units? I have 4 here. Okay. Well, so how about the minus in front of it? If you have a minus, you need to reflect on the x-axis, isn't it? Remember, the minus outside is a reflection on the x-axis, minus inside reflected on the y-axis. So you need to tell reflection on the x-axis first, isn't it? Reflection on the x-axis. Make sense? Are you following that, sir?
Yeah.
Left to right. And then we're going to go inside, horizontally translate to the left, isn't it?
Yeah.
1 unit, isn't it?
Yeah.
And the last one, vertically translate down by 4 unit. Does that make sense? Right? Okay, can you give a shot on the next 2 by yourself to get it right? So why did you decide to go for AP program? Any reason? Anyone suggested?
Yeah, my dad was like, he wanted me to do AP. And wanted me to.
Sorry?
He wanted me to go to a uniform school. So it's like,
Uniform school, I got it. But why AP? Like, why your dad wants you to do AP? Your cousins are doing, friends are doing.
my cousins did IB.
Okay.
So I think he wanted to do something more complex. And
Okay.
we wanted to set him up for university.
Okay. But do you know what the whole idea of AP?
Yeah.
What the whole idea?
It's like they expose you to like grade 9, they expose you to grade 10.
But eventually, what's the end goal of it?
They want you to get exposed to university.
Okay, I think that you didn't have the right picture of AP. I'm an AP teacher, so I teach computer science in AP. So in grade 12 or grade 11, you can take advanced placement exam run by College Board. So it's a US-based institution. So you don't even need to be in AP program to take the exam, but you need to prepare yourself. So if you're in an AP school, your school will run those exams in your school. So you can simply say to the guidance counselor, I want to take the exam, so you will pay the fee for the exam, you will write it. Now the AP exam scores are based on a scale from 0 to 5. So if you got, let's see, on your calculus, 5 out of 5 or 4.5 out of 5, it's called advanced placement credit. So when you apply to the university, it's only valid for 2 years. If you take the exam, let's say you're in grade 10, so 2025, you're in grade 10, 26, you're grade 11. So let's say in 2026 May, you're writing the exam. The score you got is valid for 2 years, so 2026 to 2028. So you will be applying to uni in 2027 September, right? So when you apply, when you ask the College Board to send those codes to the universities, there are universities, what they do, they will accept those one as an advanced credit. Even before you entering a uni, you will earn credit. So you only pay for the exam, but the universities recognize it's an equivalent to first semester credit for calculus or physics or computer science. But what that doesn't really count towards, it doesn't count towards your average they calculate in the university. So they won't use that in the average. But let's say you need to take 20 credits to graduate, and you take 5 of these, or like 3 of these from AP exam, you only then need to take 17 credits to graduate. So you're saving money. In addition, you are prepared because the content is equal in the first year. In addition, you are just prepared. You also get an advanced standing credit. That's the entire goal. And if you apply to the US schools for your undergraduate program, it's more recognitions that Canadian schools. US school, they count this as a credit. And Canadian school, some of them accept, some of them not. And you need to score really well. So for example, in Waterloo or University of Toronto, Queens, or whatever you want to call it, mostly they will expect you to get 5 out of 5 on calculus, physics. So think about, you take calculus, physics, biology, chemistry, computer science. In case that you do that, that's 5 courses. You got around 3 credits before you head in. But that's required a lot of preparation for sure, a lot of material to learn. But what most people do, they don't take all the exam in grade 11. There are exams you can take in grade 11, easy, and then they take some of them in grade 12. So people used to take computer science, if you learn it, pretty straightforward to take in grade 11. And then people who add math will take the calculus one, and then they take physics and English chemistry for grade 12. All right, so let's moving back. So you kind of ahead. So you might need to prepare for the AP calculus down the road, but just one course is not enough. You need to consider whether biology, chemistry, and physics you want to add on, or statistics. So there's around 7 courses you can take in AP English, AP History, AP Economics, AP Statistics, AP Physics, AP Calculus, and AP Biology, and AP, Computer Science. All right, let's fill out that next 2. You can actually tell verbally, sir. So I can save the time. Value of A, what do you got? Oh, 3. Value of K. 1. Value of D.
5.
And value of C.
6.
Okay, can you verbally describe when you go from left to right? So it's just left to right. So what's happening the first? The 3. What the 3 does to the curve? What is the purpose of the 3?
So vertical structure.
Well, vertical is stretched by a factor of 3, right? And then there's no horizontal transfer, horizontal compression or stretch because K is 1. But we do have a D value. What the D does? The D is move the graph to the right. So it's going to be vertical is stretched by a factor of 3, right? So vertical stretched by a factor of 3. And then horizontally translate to the right by 3. Horizontally translate to the right, isn't it?
Yeah.
By 5 units. And the last one, vertically translate down, isn't it? Make sense? I mean, vertical translate up. 5, 6. Okay, can you do the next one? Write it down. Let's see if you can get that right. All right, what's going on, sir? How that works? What's the value of A? Cool. K. You got it. D. You got it. C. Okay, can you verbally tell what needs to be done?
So reflection on the wax.
You got it. Yes.
Horizontal translate to the left by 6.
You got it.
And vertically translate down by 7.
That's it.
Sorry.
You're down by 7 units. You got it. Okay. So now we're going to be going back to some fancy stuff. So state the transformation that would apply to f of x required to obtain the following curve. So pretty straightforward, I believe. So can you quickly tell A, how would you do from f of x to A? Look at the numbers where they are located.
Vertical stretch by a factor of 2.
Yep.
Horizontal stretch by a factor.
Horizontal compression. If it's greater than 1, you're going to be compression and then flip the fraction. So 3 became 1/3. So horizontal compression by a factor of 1/3. Okay, can you do B?
Reflection on the x-axis.
Yep.
Horizontal compression by a factor of 1/2.
You got it. Okay, see? Outside is vertical always.
Vertical stretch by 1/2.
Vertical stretch by a factor of 1/2. Okay. You got a minus, yes. Reflected on, because it's -1, we don't do any horizontal structure compression, but we do reflection. Reflection on the outside is X, inside is Y. Okay, so last not least.
Vertical stretch by factor of -3.
No, factor of 3, so you don't want to say stretch by a factor of -3, so it's a factor of 3, yeah.
So that'll be reflected on
Reflected on the,
x-axis.
yeah. So we do that left to right. So we're gonna going back to reflection on the x-axis, vertical stretch by a factor of 3. So always left to right, okay? Then what's happening here?
Horizontal stretch.
Yes.
By factor of 1/2.
2. You flip that fraction set. Inside you flip it. Okay, 1/2 became 2. 2 became 1/2. Make sense?
Yeah.
All right. So number 2 for your homework to play around. So you match the curve based on the transformation. So you know how to look at for it. Left and right. So if you want to see, if you see a horizontal transformation, ask yourself whether it's a left or right. So if it's left or right, you know the parent function from the origin. Left means it should be moved to the left side of the origin, move to the right side. Then look at a vertical shift, up and down. Is it above x-axis or came down, right? Now, after that, you need to look at the graph, whether it's being narrow in this direction, right? So if it is narrower in this direction, I mean, a vertical direction, that is something to deal with the stretch, vertical stretch. Wider in y direction, something to do with the, again, vertical, right? And on the other hand, it is going to be stretched this way, that meaning horizontally compressive, isn't it? So that's something to think in questions. I'm not going to do it. So you will play around with this C. Now, we need to see how we can apply some of the transformation to graph it. So I will do the first one, you will do the second one. So do you see the graph? This is the original graph. They wanted a graph -2 f of x. So what do we do -2? We reflect all the points on the y-axis, it's an x-axis, isn't it?
Yeah.
So that means this point is going to be reflected simply here. This point is going to be simply reflected there. Make sense? Are you following that, sir? And this point that is going to be 3 units going to be reflected here. And then we can think about this point is going to be reflected there, isn't it? And then we can think this point is going to be reflected here. So the reflection one, I'm going to draw in green. So you can see the reflected one I'm doing on green. That is the reflection, isn't it? But in addition to reflection, we also need to do 2, isn't it? So 2 means stretching by 2. That means all the y coordinate will double. So if I double all the y coordinate, let's use the different color. This is 2 is going to move over here, right? This 3 is going to move over here. Now, the next point, this 3 is going to move over 3, 6, double, isn't it? So 3 is going to be double, 1, 2, 3. And this guy, 3 is going to be double. It's going to be here. So what that will do, this is going to be go like this, the final curve. Final curve, it's something like this. Did you get that picture, sir? You see how they did that curve? Yes, no, no, yes.
Yeah. Yes.
All right. So I identify some key coordinates, isn't it? So I just identify some key coordinate to work with. So let's going back to the key coordinate of the original curve here. So the key coordinate of the original curve, so we're going to list this. So what we work with. So first I work with the key coordinate. So I'm going to do x and y. So I work with -4, comma, this is 2, isn't it? This point, right? Then I work with my key coordinate. What are the key coordinate? The other key coordinate I work with, this is -2. -2, comma, that is, this is 2, this is 3, isn't it? Then the other key coordinate I work with come back here, which is 1 comma, which is -3. Then the other key coordinate I work with, you can see this guy, 3 comma, that is also -3. Did you see that? Do you see the coordinates I work with? Okay, now what I want to show you, this time, I didn't generate the table. I simply just used my technique. But I'm going to explain how do I generate the curve. So this is what we're going to do. You're going to memorize it. When you have an x comma y in a given point, the transform one will be go like this: x over k plus d, ay plus c. So let's explain what this one. The horizontal transformation will divide. So k value, that's horizontal. We need to divide the x coordinate. The d is moving left or right. So the x will be shifted to the right or x will be shifted to the left, isn't it? A times y coordinate stretched by a, the first value. C, moving it up or down. So what we're going to do, sir, we're going to going back to C. On this graph that we want to do, this is f of x. And then it's going through -2 f of x, isn't it? So let's identify some of the key numbers. So what is the value of A? A is -2, isn't it? A is in the front, isn't it?
Yeah.
So therefore, it should be -2y, c is 0, isn't it? Because there's no c here. You see that there's no c, isn't it?
Yeah.
So c is 0. K value is 1, so its xd value is 0. So technically speaking, when we do this, we can simply generate it. X doesn't change at all. How the y's turn to be, double it, -4, -6, +6, and then double it, +6. So all I need to do is, I need to plot these pair of points on my graph to generate it. Did you see that? To generate my black curve, I need to use those points. Let's check it out. -4, 4, and then -2, 6, and 1, 6, and 3, 6. You see that? Are you seeing those points?
Yeah.
Okay, so this is for this blue curve, these are the coordinates. Can you use that coordinate to generate the table for B, C, and D using this formula? Using this formula, can you generate a table? So let's see if you can generate a table for the second one. So K is 2. Did you graph it second one, sir? You get the points? Struggling. Okay, so let's going back to that table. So we're gonna think about the table. So what is the A value, sir? A value for the second graph. A is 1. Okay, so that is going to be Y. What is the C value? Okay, C value is 0. So now what is the K value? What is the K value, man? 2. So what's X over K, isn't it? So it's going to be X divided by 2. What is the D value? No D, isn't it?
Yeah.
So going back to the original curve. So let's look at the green one, the first one. So first point is -4, isn't it? So here the -4 is going to divide by 2. So it's going to -2. Y doesn't change. Then we got the -2. Come and watch it. -2 we need to divide by 2, isn't it? So -2 divided by 2 is -1, 3. 1 divided by 2, 1/2, -3. 3 divided by 2, 3 over 2, -3. Make sense? You see how I got the points? Are you following the technique? Okay, can you graph it? So graph it, and then I want you to do the other one in the same way.
Y values don't change. Just
Yes, because A is 1, and then your C is 0. So the graph won't be stretching vertically and won't move up and down. So the Y value will be the same as for the original Y value. The only X is going to change. You graph it using those coordinates. You're getting the idea, right?
Yeah.
Okay. Grab it, okay, let me see. So when it's come to this one, as I say, it's better to have some color pads, so we'll be making quite good, so 2x, and then you can clearly see what happened to the original graph, it's not printed. That's weird. The original graph is not there. The one I gave. The original one. Oh, original is there, okay, I'm not seeing that, okay, the pencil color is, okay. So you look like you didn't go the first one, you go the second one, and you can clearly see it's coming inside. So we are compressing horizontally, it's coming inside the previous curve. Okay, so can you generate the points? Where you generating it? Can you generate the point for the third one and show me how to get the points for the third one? I want to see the third points. Generate the table for the third one.